Okay, we're going to be skipping over example number 42. If you want to do that one on your own and solve it and graph it, at the very end of this video, if I have a little extra time, I will show you the solution to that. So 42, you might want to note that, do it on your own, and expect to possibly see a solution at the end of this video. So moving on to what happens when this negative comes up. Now in part for example number 43a, it can be avoided to have to reverse the sense of the inequality by getting the variables to stay positive, moving them over to the right hand side. So let's look at it as solved in that method. So we say, okay, got a bunch of fractions, let's clear this thing first. So we're going to clear it by using our LCD, which is a 4 here. So clearing still applies, so multiplying every single term by 4. So 4 times every single number, regardless of whether it is a fraction or not. Remember, that's not our defining thing of how do we decide to multiply by this LCD. It's every term has to get multiplied. We multiply and we cancel, and then we multiply out. So our first term on the left looks like 3x minus 4 times 1, because there's nothing to cancel, 4, greater than or equal to 4 times 2, which is 8x, again nothing to cancel, plus, and the 4's cancel, so 1 times 1, which is 1. Now it's cleared, so it's easier to see how to solve the problem. Now if we wanted to keep the variables positive, which a lot of times we do, right, we would move it over to this side, and we're not going to see any problems with the inequality, right, switching the inequality, having to reverse the sense of the inequality, because we're not going to multiply or divide by any negatives then. 8 minus 3, which is 5x, and then plus 1, and then move the numbers over to the left hand side, and we see negative 5 is greater than or equal to 5x, and multiply by the reciprocal of 5, which looks like division, of course, because it is. And now we see that negative 1 is greater than or equal to x, and we know we like to see that in standard form, so we put our variable over here on the left, our number over here on the right, and we see that this inequality points to my x, right? So I pointed out to my x again, and that's what it ends up looking like. And so that's what we see is x is less than or equal to negative 1. And then we can go here to the negative 1, and we can indicate that with a bracket, and then that it goes off this way. And my interval notation, negative infinity is the left thing that I see, never can be included, and then up to the negative 1 with a bracket. Now, the other way of looking at this is to not try to keep the variable positive, but to move all the variables over here to the left and the numbers over to the right, and this is what's happening then. And that's why 43 and 44, we have two examples with the same numbers in them. So I'm just going to do these simultaneously. The clearing process would have still gone the exact same way, and now instead I would be moving the 8 over to this side. So 3x minus 4, and then greater than or equal to 8x plus 1. This time I'm going to go ahead and I'm going to move the 8x to the left-hand side. And so when I do this, what I'm going to see is a negative 5x on this side, and then minus 4, and then greater than or equal to, and there's 1 over here, and then moving the 4 to this side, and now I'm going to see that this is a negative 5x, and then that's greater than or equal to a positive 5. And here's the defining step. My defining step this time is going to be that I have to multiply or divide by a negative. I'm going to do this in a different color. I'm going to do it in green to show you that watch what happens. I'm going to do this, and now I'm going to have to flip the sense of the inequality. So rather than a greater than or equal to like that, I'm going to make that thing a less than or equal to like that, and now I have x is less than or equal to a negative 1, and that negative 1 again is because I multiplied by or divided by a negative, and so that division by a negative flipped that inequality, and you see it's the exact same answer.